Yeah, so any method that we have here that uses that constructor, so anytime that we try to use this constructor, new fraction 3, 4, right, or any two numbers here, so that's the constructor, this is the constructor right here. That's the constructor right here. So any constructor, anything that uses that constructor has to either say throws exception or use a try-catch block. So this is a little confusing for now, but what I want you to think about is here, first of all, again, if the denominator is 0, rather than the user, us telling the secondary programmer what to do with their program, because nobody likes to be told what to do. So that's what we're doing here. We're telling the secondary programmer, hey, you can't do that, and then we're setting the denominator to 1 so that the program can continue. Rather than doing that, we're forcing the secondary programmer to deal with it. How do they deal with it? With a try-catch block. And to tell them that this method throws an exception, we have to put it in the method header, throws exception. And so we had another compiler error down here for our times method, because our times method also called that constructor. So that means that this, because it calls that constructor just like we call the constructor here, we either have to put a try-catch around this line of code, because we could do that, or we could pass it on, that's what it says here, or pass it on. So we can put throws exception here as well, and then anytime somebody uses the times method, well, because the times method uses the constructor, the times method now, anytime you use the times method, you also have to use try-catch. Hopefully that makes sense. So, what we have here now is, even though we're not putting a 0 in the denominator, we still have to put it in a try-catch block, because like I said, the compiler has no idea that this is a 0 or a 4 or whatever number. The compiler doesn't know what it is until runtime. So we have to put it in a try-catch block. So now, if I try to compile this, we still get this compiler error. And this one we should know from before. It's saying F1 cannot be resolved to a variable. Why? Because that's a scope issue. Fraction F1 was created inside this try block. So what we could do to get out of that is create fraction F1 and then say F1 gets new fraction in there. But we might still get a compiler error here. Let's check it out. Yeah, so we still get an error saying it might not have been initialized. So what happens if we try to do this? So what the try-catch block means, first of all, let's start there, is it's going to try to do this line of code. And it may throw an exception, is what it's saying, depending on what happens at runtime. So if this happens to be a 0, it would throw an exception in this case, because that's the condition that we put in our constructor up here. If it's 0, it'll throw an exception. So in this case with 3, 4, it's not going to throw an exception. But if it did throw an exception, if this was a 0, then it would end up down here in the catch block. And that means that this line did not execute correctly. It did not run fully. And if it doesn't run fully, then F1 doesn't have a value. Because before we could even give it values, it threw an exception, right? Because that's what the constructor is supposed to do. It's supposed to create the object and give it values. Before that could happen, it threw an exception. So it never got to actually giving it the values. And so how can we print it out down here? That's what it's saying. F1 may not have been initialized. So to get around that, we can assign it like a the default kind of 0 for objects, which is nothing, which is null. So the default nothing for objects is null. So now that compiles. And so if we put a 4 here, we hit the compile button, and it compiles, and we hit run, and it prints out 3 over 4 just fine. So what happens here is we've created a fraction, 3 over 4 comes in here, 3 over 4, because neither of them, or because the denominator is not 0, it just assigns the values and assigns the numerator, goes back, no exception was thrown, And so it continues on and nothing happens. What happens if it's 0? So now we hit compile and it still compiles because it's in a try-catch block. And what happens now though is because this line fails, it throws an exception. So it comes in here, and because D is 0, it throws an exception. So an exception is now thrown on that line. And what's going to happen is it's going to end up inside this catch block, right, where we have not written any code, because that's optional, but you definitely should write code in there. So let's hit the compile button and let's run that. And so now it just prints out null, because this line of code didn't get executed, right? It failed. So let's fix that so that in the catch block we can say system.out.println can't have a denominator of 0. Okay. So, and maybe this, we only want to print it out. So we don't want to print out this null. Maybe we only want to print it out inside here. And in that case, we didn't have to do this at all. We could have just said, we wouldn't have a scope issue. We could put the fraction f1 in there, and then print that out in there, and only print it out basically if this line of code does not fail. So when an exception is thrown, it's thrown on that line. That means nothing else continues in that try block. So this line number 16 will not get executed if this is 0, like it is now. So we hit compile and we hit run. This line of code fails and throws an exception. This line doesn't ever even run, because as soon as it hits that exception, it jumps into the catch block and it prints that out. Okay, so now who are we talking to when we say can't have a denominator of 0? We're the secondary programmer in this class. We're the one that put the 0 there to begin with. So who are we talking to? Well, like I said, this could be something that you take from the user. It could be the KB reader .nextInt, where you grab it from the user, and you could be talking to the user in that case. So I don't want to go through all that because it's going to take too long. But yeah, that could be the user, and you could be talking to the user in this situation. So that's one way of dealing with this. Now, why does this give us the second? Why is this beneficial to do over what we had here? Why do all of this with the throw no exception? It's so much more complicated, and with this try catch blocking now. Well, what it does is, first of all, it gives the freedom to the secondary programmer to decide what they want to do. Do they want to, print out a different message? Do they want to go a different route? For example, I could put a Boolean in here, and this could be inside of a loop where I go back and ask the user for a different value for the denominator. Secondary programmer has all the options in the world to do whatever they want. Whereas the way we had it before, that primary programmer decided what they wanted for you. And they set the denominator to 1, and they set this message. For example, you might not like the word hey as the secondary programmer, but you know what? You're stuck with that now because that's what the primary programmer decided to print out. So this gives the flexibility now to the secondary programmer to be able to decide what to do. But it also forces the secondary programmer to realize that there is a problem if the denominator is 0. So it forces the secondary programmer to consider that with the try-catch block. So that's this side right here. The checked exceptions that are caught by the compiler. The secondary programmer must use a try-catch block to deal with it, right? And in that case, when they use that try-catch block, then they have to deal with it, and so that it doesn't get to the secondary programmer, just like it becomes a compiler error, and they have to decide what to do with it. On the other hand, and what you can do for your final project here when you're using this, just to avoid, because this can get rather time consuming anytime that you want to use a constructor, you have to put a try-catch block around it. So rather than doing this, what we can do is change this from a regular exception to what we call a runtime exception. Now over here, on the runtime exceptions, these are not caught by the compiler. So that's kind of sometimes a bad thing because you're not forcing the secondary programmer to deal with it. But because it's a runtime exception, you don't have to put that in there. You don't have to declare it. And you can take this one out too. So now that'll still compile. Okay. So it's a runtime exception. It's not caught by the compiler. But like the arithmetic exception, it'll just show up for the user to see. And so that can be a bad thing. You may use the try-catch block, right? But in the checked exception that we had before, that wasn't a runtime exception, you have to use the try-catch block or pass it on, right? Here, you can use it. You don't have to as a secondary program. So I can leave the try-catch block in there and hit the run button, and it'll still work, the same way that the checked exception worked. But because it's a runtime exception, we don't have to put try-catch blocks around it. So now, what will happen? It still compiles because it's a runtime exception, not a regular exception. It's a runtime exception, and so it'll compile. But now what happens when you run it is you get this runtime exception, right? Hey, you can't do that denominator set to 1. Well, where did you get that from? That was from what we passed into our constructor of the runtime exception here, right? So that message is coming up here. And so now this exception gets all the way to the end user. So that can be a bad thing. But the benefit of using the runtime exception is that the secondary programmer doesn't have to be annoyed by using the try-catch blocks all the time that they want to create a new fraction. The benefit of the checked exception is that the secondary programmer has to deal with it and decide, put the try-catch block in, and the catch block kind of deals with the problem before it gets to the end user. So maybe the end user is asked again. So this just stops the program. The program stopped. The user can't continue. They have to start the whole program again. So that's a problem for the user. The user will be annoyed. The try-catch blocks is probably going to annoy the secondary programmer. So either way, somebody's going to be annoyed. It's probably better that the programmer deals with it than the end user, and the programmer's annoyed. Because the programmer just has to program it once, the end user might be using the program over and over and over again. And so the checked exception is probably the better option for the secondary programmer to deal with that and more gracefully handle the problem and ask the user to enter the information again, and so on and so forth. For your final project, you are allowed to use the runtime exception. Okay, but I just wanted you to be aware of. So anywhere in the handout of the final project where I say throw an exception, you're allowed to use a runtime exception. But I just wanted you to be aware of both types of exceptions and when to use what and in which situations. Hope that makes sense, and I'll catch you next time.